So all the rules is here again: power functions, exponential, logs, and circular functions. Okay, so the antidiff for all of that. And yesterday we just go over those 8 questions, talk about how to antidiff a lot of things. Well, I think students always confused about exponential and power functions. Like they always add 1 on the log function, like an exponential function in the end, like they're not on purpose. They just think about power, I should add 1 by power. So just be careful with the power function and exponential function. So power function is x is the base to the power of n, and for exponential is x is in the power. So that's how you distinguish exponential and power functions. Okay, so today we're going to learn something really fun, but like really important. Okay, this is really important because yesterday, okay, so 3e to the power of x. And yesterday I have asked you to use 20 minutes to differentiate all the functions already. So, okay, what we're trying to do for this exercise is actually called integral by recognitions. Okay, so basically you can see the question for the second part. It asks you to integral 3ex over 1 plus ex. This is something you don't know how to antidiff. I can't divide them. Can you see I can't separate it? That's the first thing. They are in something divided by something form. And also this is not belongs to any of the thing we learned. It is exponential. Yes, it is exponential. But it's not a single exponential. It's something divided by something. I can't antidiff that using my current knowledge. So now I want to use something to help me. This must be a 2-part question. You have a first part A, differentiate something, and the second part B, to antidiff something. It must be 2-part question. When you see the first part A asking you to diff something, and the second part asks you to antidiff something you don't know, that must be this type of questions. So what's the idea we use in this exercise is, if we have fx, we diff that, we will have f dash x. So definitely integral f dash x dx will give you back to fx. So that's the main logic we use here. Well, it's very easy logic. We diff something, we get f dash x. Now we antidiff f dash x, we definitely get fx. So that's something for sure. Okay, in the antidiff f dash x, all of f dash x or part of the f dash x will be what is asking. Okay, so something involved in f dash x must be what is asking. Maybe all of f dash x or maybe part of f dash x involve the thing what I'm interested in, like is for part B. So let's just have a look at example 2. Differentiate log e 1 plus ex. You know differentiate log is g dash x over gx. Okay, g dash x over gx. So d dx of log e 1 plus e to the power of x, that will gives you e to the power of x over 1 plus e to the power of x. Okay, that's something I know. G dash x over gx. Okay, yesterday you should have that already. So now what, well, that's part A. So part B now asks you to antidiff this. Well, I have no idea on how to antidiff that. But observe the f dash x you get here. This is really looks similar. Okay, looks similar to this one, Okay, it's just the coefficient is different. So what I will set up first is go backwards. Like the first thing I will set up is go backwards. Integral of ex over 1 plus ex dx. That will definitely give me log e 1 plus ex. Okay, I diff that, give me that, and antidiff that will go back to log e 1 plus ex. Now what I need 3 lots of that. Okay, I need 3 lots of that. So I will times this side by 3. No problem with that. Then the right hand side needs to be times by 3 as well. Also, I want to let you know, like the 3 times inside or times outside, they are the same thing. Because you not antidiff the 3. The 3 is just a number times with it. So the 3 either inside or outside, it doesn't really matter. I will talk about the properties for integral later in exercise A or B. Can't remember which exercise is that. But like, it doesn't matter. The coefficient, where's the coefficient doesn't matter. Whether I diff the x only or diff the 3x only, it doesn't matter. So the 3 is something not really important. Whether inside the integral sign or outside the integral sign, they have the same result. So I just times the 3 on both sides of the equation. Therefore, what I will get is, I can put it inside as well. So I get 3 log e, 1 plus ex, and then plus c in the end. Like you plus the c at the last step. Okay, at last step. You can, well, I'll explain why we add the c in the end. We can add c here. Okay, and then y times 3, then this will become a 3c. Yeah, 3c just a constant as well. Like c is any number, then 3c is still any number. So, well, that's just plus a d in the end. So there's no point to add the c that early. In the end, we just add some constant, but like can be anything. I just use a variable to represent that. So I can just add the c in the end. Okay, last step. Yeah, example 2 is easy. It's just like introduction on how to do this. Okay, like diff something, get the f dash x. Now we anti-diff the f dash x, we'll definitely get fx. So that's the idea we use in this exercise. Let's have a look at example 3. Well, yesterday I find a really terrible thing. A lot of you forget how to use chain rule, quotient rule. Okay, so count diff already. Well, we only finished sec 1. We should remember that. You still have sec 2, and you still have exam. And in probability, you still need differentiation and anti-differentiation. So you will use diff and anti-diff for the whole year. And like very, very important in exam. So really make sure you remember chain rule, quotient rule, and product rule. How to diff and how to anti-diff is so important. Okay, calculus so important for the whole year. Okay, so differentiate that is, I can say d dx of x e 3x. Well, I can diff the x first, and I get 1. So that's 1 times that. And I can diff the other one. So that gives me 3x e 3x. I will have that. Can you see this is the f dash x? Okay, this is the f dash x. Let's say this is part A. This is the f dash x. Now I want to anti-diff. What I want to anti-diff? What I'm looking for is anti-diff 5x e 3x. Okay, this is what I'm trying to anti-diff. Okay, don't forget the dx in the end, because the dx in the end was 1 mark for the whole paper. Anywhere you lose the dx, you lose 1 mark for the whole paper. But like only 1 mark. You can lose all the dx on the paper, and that's 1 mark. But like it's not worth to lose that mark. Yes? Yeah, you still keep. Yeah. Like when you have that, you must have the x. You have the big S, you must have the x. Like they are together, they can't separate. Like it's not only this means integral, it's integral regards to x. Like the dx must be there. Okay, so this is the, okay, you can see last time the f dash x, the whole thing is the anti-diff, what the anti-diff want. But now only part of this, or you don't need to care about the coefficient, just care about the terms contain x. The coefficient can change. I can divide constant, I can times constant. But like the x can't change. So the x times e3x is what I want. So part of the thing is what I want. Okay, part of the thing is what I want. But it's alright. B is always start from the integral. Okay, integral is 3x plus 3x e 3x dx. That will definitely give me this. Well, I don't need to plus c in this stage. It's not my final answer yet. So that's the first step. Anti-diff the f dash x, I will get fx. Okay, anti-diff the f dash x, I will get fx. That's the first step. But now I will separate things. I will separate that. And I will separate that. Okay, I have done nothing, just basically separate into two antidiff, like it's just a way to write it. And what you can see is this is kind of the thing what I want. Okay, this is kind of the thing what I want. Like I need a 5, I don't need a 3, but I can divide a 3 and then times a 5. That's what I can do, but not now. Okay, not now. I have another thing. Well, that's already given. I have this, but I know how to antidiff that. I know the answer for that. This gives me, well, this gives me a third E3x. Okay, antidiff that gives me a third E3x. I can evaluate part of that. Okay, I can evaluate part of the antidiff. So what I will have is, well, I can put the 3 outside. I said it's the same thing. Equals to what? Equals to x E3x minus a third E3x. Okay, very simple subtraction step. Okay, just substitute that. Move that to that side. So leave what I want on one side only. Now what I will do, I don't want the 3, but instead I want a 5. Well, basically you can't add by 2, like you can't add things here. But I can times this by 5 over 3. Okay, then the other side needs to be times by 5 over 3 as well. Well, divide the 3 and times the 5. Okay, I want to cancel the 3 but gain the 5. So divide the 3 and then times by 5. So now the 3 and 3 just gone. It will be integral 5x E3x dx equals to 5 over 3x E3x minus 5 over 9 E3x. Now I can plus the C value. Yeah, this is complex compared to the previous one because that involves, okay, that involves part of the thing I can evaluate, but part of the thing is what I want. So I need to move things from both sides of the equation. Some from here to there, some from there to there. And I need to divide the coefficient I don't need and I times the coefficient I want. Okay, good. Okay, that's example 3. Okay, example 4. Okay, A is differentiate. It's always differentiate something and antidiff something you don't know. It's always like that. But the question is not going to be as simple as this. Okay, it's not going to be as simple as this. It's not going to be that straightforward, like giving you that, giving you that. It's normally in some diagram involved and ask you, part A is differentiate this function, blah, 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 and now find the area under the curve for that graph. Like you learn how to find the area under the curve. It's still anti-differentiation. So it will be in the context. It's not going to be diff that, anti-diff that. Like it's too straightforward. But the idea is like that. Is you using exactly the same way to find things. But it's just like the way they describe it is not going to be that straightforward. I'll show you examples later when we finish the whole chapter. I will show you what the question will look like. It's quite important because almost every year I see question relate to that. And normally it's in part 1 exam. Part 1 exam, last 2 questions seems to be this type of questions. Okay, so d dx, x times that. Times the x first, I have sine 3x. And plus 3x cos 3x. Okay, diff the x first, I got 1 times sine x, and I diff the sine 3x, I got 3 cosine 3x. Diff sine will give you cos. Okay, so I have that. So B is asking an antiderivative of x times cosine 3x. Okay, that's exactly this part. See? Well, you can include the coefficient. Doesn't matter for the coefficient, but like that's what I want. Okay, the second half is what I want. So because it satisfies first diff something, second I'm diff something I don't know. So I will directly start with the step sine 3x plus cos 3x cosine 3x dx. That gives me x times sine 3x. So I can separate this. Well, I don't really need to separate. How to anti-diff sine 3x? What the answer will be? Anti-sine 3x. Sine will become what? Negative cos. Good. So sine become negative cos. So the 3 is the coefficient. So negative 1/3 cosine 3x. Okay, anti-diff the first part. But the second part, I haven't done anything yet. So I can put the 3 out first. As I said, doesn't matter whether you put the 3 in or put the 3 out. Doesn't influence the result for x. So I can write in that way. So 3 integral x cosine 3x dx. That equals to x times sine 3x plus 1/3 cosine 3x. Okay, plus 1/3 cosine 3x. Now I can divide everything by 3 again because I only need x cosine 3x, the antidiff of that. So that's 1/3 x sine 3x plus 1/9 cosine 3x. Everything divided by 3. And now that's the final answer. We plus the c value. Okay, basically divide 3 on everything. Any questions? Well, the question will be only looks like this. Okay, so this is the only way you can see that. I don't think we have any question for that, but I think yesterday we have a lot of difficulties to find the first part, the differentiation for this question. Okay, we struggle a little bit how to find, all of us finally find out how to diff that part. Well, all of your answers correct, but just how to make it into the correct form. Okay, how to make it into the correct form. So we have 1 plus sine over cos. Well, don't worry about the hence part yet. Let's just find the differentiation. d dx 1 plus sine x over cos x. Okay, this equals to square the bottom. Okay, the bottom becomes cos squared. Now I will diff the top part. We got a cosine x. Okay, 1 becomes 0, diff sine become cos, and times with the bottom, so cos squared, minus 1 plus sine x. Well, keep the top, diff the bottom, you have minus sine x. And you have minus sine x. Okay, can you see this minus and this minus becomes a plus? So that becomes the plus. Now what we have is cosine squared x plus sine squared x plus sine x. That's the top. Over cosine squared x. Now I see quite many of you do something after that. I think it's because yesterday I teach you a plus b over c equals to a over c plus b over c. And I see a lot of you separate the function here. So you do cosine over cosine is 1, and sine squared over cos squared, maybe that's a tan squared, and sine over cos, you do that. Okay, nothing wrong with that. Okay, you can do that. But I want you to think about what you want to achieve in the end first. Like the question, you can't just say whatever I can do, I just do that. It's more about the thinking. At the beginning, you may can't think about that quickly, but you need to try to think what I want to achieve in the end. What I want to achieve is 1 over 1 minus sine x. That's what I want. That's a single fraction. Okay, that's a single fraction. If that's a single fraction, then you separate things into 3 terms. How you can combine that back to 1? You still need to combine it back. So that's why I said you shouldn't separate it at that stage. It's nothing wrong to separate it, but like you will never achieve what you want. Like I want to show it is 1 over minus sine. And also you want to think about the denominator. How a cosine squared can become the sine. Okay, so how the cos become the sine. That's also something you need to think about. So why? Like I need to say, I'm trying to work towards that. So how we can get the thing we want. So the bottom is very obvious. If a cos can change to a sine, that must be 1 minus sine squared. That's what I'm thinking. Okay, that's when I just the first time I see this question, I see the bottom is something sine and also 1 involved. I will think about 1 minus sine squared. I know it's not exactly the same, but at least it looks better than cosine. Okay, it looks better than cosine. Then I look at the top. Okay, I look at the top. Well, top is just a 1. I don't have sine, I don't have cosine, I don't have anything. So sine cosine will give me a 1. Okay, sine square and cosine square will give me a 1. So that make me have 1 plus sine x. That something really looks good now. Like it really looks similar to what I want. Okay, but not yet. And something you need to think about is what the bottom can further change. How I can further change the bottom. Well, it's a difference of perfect squared. It's 1 squared minus sine squared. So it's 1 plus sine x and 1 minus cos 1 minus sine x, not cos. Okay, it's sine x minus sine times 1 plus sine. Okay, so a plus b times a minus b is the difference of perfect squared. And now I can divide this one and this one. So in the end, what I will achieve is 1 over 1 minus sine x. Okay, this is not, I'm not only giving you the answers, I'm trying to let you to think why I'm doing all of this step, why I'm not doing something else, why I can't separate the functions. I can't separate it because my answer, final answer is a 1 fraction. Okay, so why I change cos squared to 1 minus sine squared, that's because I see a sine at the bottom, so that's the only way I can change cos squared to sine. Why I do cos squared plus sine squared equals to 1? Well, very, like, reason is like I need 1 plus sine, like I need the 1 there. So I see the top is a 1, so I want to make something look similar to the bottom. So that's all the thinking I have for this question. So it's a lot of formula, well, it's not really a lot of formula involved. It's only formula involved for trig is sine squared plus cos squared equals to 1. And the other formula involved is DOPS, the difference of perfect square. That's the only 2 things we have. Okay, so in this question. Now what I want is, okay, integral of b is integral of 1 minus sine x dx will equals to 1 plus sine x over cos x. Okay, well, I hope you can see the coefficient difference between this one and that one. So that's a 3 over 2. Okay, and I can times the 3 on the numerator and 2 on the denominator. So that's 3 plus 3 sine x over 2 cos x plus c. Then you can factorize the top. 2. So 2, get 2 out, that's 1 minus sine x. So that's 3 over 2 times that. Okay, so that's this exercise. Any questions? Okay, that's the full working here. Okay, so we have about half hour left. What I want you to do is, I will circle some questions, not many. I will circle 4 questions, and I want you to do that now and hand that in to me. I want to see like you're working. Okay, so just go for next page. I want you to do this question. Question 8, question 2. 8 to 7 and 3. 2, 3, 7, 8. Okay, I want you to do those 4 questions. Just get one piece of paper, just work on the paper, write every step clearly, and just hand that in to me after half hours.